So, hello everyone, this is Akshay and welcome back to our GFG POTD streak of day 111. So, yesterday I was very busy here. I know this video is very late as of now, but somehow I have made some time for my office hours and let's do this. So, today's question name is maximum bipartite matching, and let me open the paint first. So, let's read the question and see what we can do for this question. So, it's a medium category question with the points 4. So, there are M applicants and N jobs. So, each applicant has a subset of jobs that he or she is interested in. Each job opening can only accept one applicant and a job applicant that can be pointed for only one job. So given a matrix G, M rows and N columns, G and ith denotes the ith applicant is the interested. Okay, so I is the person. So let me write. So G of ij is nothing but I is the person and J is the job, right? So let's get back to the question and find the maximum number of applicants who can get the job. For this test case, if you have dry run it, that how the input output are getting. So for m equals to 3 and equals to 5, they are saying their number of jobs is 5. That is, you can see these are the 5 jobs and this is 3%. So for one job, you can pick up these jobs, right? Where there is 0, you cannot take up that job, but you can take rest of the 4 jobs. Similarly, for second and third row. So the output is 3, right? So let us dry run that how this dry run is happening, and then we will jump to the pseudocode and decoding section. So these are saying that there are 5 jobs, right? So let me write it as J1, J2, J3, J4, J5, right? Or let me write it horizontally then. Okay, so let go this. So we have 3 persons. So let's say we have P1, we have P2, and we have P3, right? So let's match the jobs now. Now P1 is capable to take 4 jobs, right? That is first job, second job, fourth and fifth. So I will match the columns, that is 1, 2, 4 and fifth, right? Similarly, the person 2 is capable of taking just J2 and J5, right? So let's use a different color, that is J2 and that is J5. And similarly, the last one, the third person is again capable to take the job of G1, G2, J4 and J5. So let's make J1, J2, J4 and J5, right? And what is happening that is, there is one possible assignment. There is one possible assignment which says that the first the first applicant is the first job. That is person one is placed here, and person two is placed here. And you can see there is a line also from P2 to J2, and there is a line also P1 to J1. P1 to J1 line, it simplifies that P1 has the option of take up the job 1 as well as job 2, 4 and 5, right? That's the edges is representing. Now the person 3 can take up the fourth job. Okay, so person 3, is it having the third applicants can take the fourth job. So it has the structure with J4, it has the line between J4, so you can see that the P3 can be here, right? But how do we solve the problem? Like, is it that the availability of jobs the P1 has, right? The first job the availability has just assigned it to P1, and the first job the P2 has, that is this J2, the availability, the first job, the available first job for P2, do we assign it as P2? And similarly for the first job, or let's say maybe the third job available for P3, because J1 and J2 is already taken, so it just have one option of taking the J4, so it's P3. So do we follow this conventional way of whenever you are getting a first available job, just apply to it? Can we do that way? Because if you consider this example of P1 and P2, and let's say J1 and J2 is here, and the lines are like this, that P1 can take both of the jobs, but P2 can take only one job. So if you go with the conventional manner that the first available job, just assign it, if I just do that, then I will say that P1 will take J1. But what about P2? P2 can only take J1 and not J2, right? So what I need to do, that in this case my answer will be 1, right? If I just take the first availability job and assign to the first person, right? To the respective person. But what if I do in this different way, that let's take P1 will take the job 2, and then J1 will be free handed and you can assign it to P2, right? Then the answer will be 2, right? So this, from here, my intuition is, from this dry run I just show you, I can say that our solution will be like this. For every person, you have to check all jobs. Don't mind my handwriting when I am speaking, just follow along, and you can use your own pen and paper to write it along with me, right? So you have, for one person, you have to check all jobs, and the best practice will be do it to using recursion, right? Using recursion, and also, so that means So let's say this person is nothing but, let's say, a pointer u, and this job is nothing but a pointer v, right? So what I'm saying is that I am making a connection between u to v, and if it is only equals to 1, that means that there is a job availability from u to v, right? So here comes the two statements, right? That if the job is possible, right? If possible and not assigned to anyone, not assigned to anyone, right? Then assign it to the particular person who just came for it, right? That was our first intuition we were doing. But the second intuition, we see that if you follow that step, you will not get an optimal answer, in this case 1 and 2. So that means that if possible, if the job is possible, that is, this condition must sustain first of all, and assigned job, like assigned job is assigned to another person as well. Let me write it that way: assigned to other person as well, right? I was seeing that P2 can be assigned to this J1, right? But that was already assigned to P1, right? So P1 has to take this job J2, then only we can get the optimal answer. So that's this case. This is the second case, the first case, right? I can see that. Another person is nothing but check if this person can get the another job, right? This other person can only be assigned only for this another person U and V is equals to 1, right? That is it. So that means for this we have to, for each and every person, for each and every person you have to check all jobs, right? So that means that we will have, if I just write some pseudocode for you and then we'll complete the code, like for each and every person, for I equals to n, right? So n is the all the jobs. So initially all the jobs are available, so I will say I plus plus, right? And also I can see that I need to maintain a visited array, because if you do not maintain it, then it will, like, the first person with the job has been assigned, it will check for the another job, and it will keep on checking in the loop, right? So you have to make one visited array there, right? Okay. So what I'm saying is the logic of maintaining an array is, let's say that we have one more job that is J3, right? So I can clearly see that the P2 cannot take the job J2 or J3. So it is saying P1, can you take the job J2 and J3, right? So when P1 moves from J1 to J2, it will mark the J1 as visited, that I have already visited this thing. I do not want this thing to visit again, and it will move on to J2. And then when it will move to J2, the P1, so P1 when moves to J2, it will again mark J2 that is possible to take up this job, right? Similarly, it will maintain the array and will continue moving in, right? So according to our code, if we dry run this case, like if we dry run this case, then what will happen is that let's say I'm assigning P1 to J1, right? I am assigning P1 to J1, that is for sure. So there is no problem. But as you can see, the P2, it goes to the first edge, that is J2, right? So I can clearly assign P2 here, right? That is no problem, right? But when P3 comes, the first job here is J1. So he or she will ask that J1, can you move? Can you move to the another job? And you can see that if you can take another job, right? So P3 will move here and it will go to J1, can you search for the another job that you can take? So J1 will say, okay, the next job available to me is J2, right? It has the, so now the P2 P1 will come here and it will ask J2, it will ask P2, because P2 was the person who took the job, right? So it will ask P2 that P2, can you move forward in hope that you will get a job available there, right? So P2 was initially connected to J2. It will mark the J2 as true. It will go to J3 and it will say, okay, there is a no line between my U and V is not equals to 1, so I cannot take J3. Then I will go to what, J4. There is no line again, right? And I will go to J5. So J5, the P2 and J5 has the connection, and it will say that, okay, I can rely here, right? And now you do not need to move the any persons to any other job. All the persons, all the jobs are satisfied, right? So according to our code, the answer will be like this: the P3 will be like standing at J1 and P2 at J2, P1 at J2, P3 at J1, and P2 at J5, right? So I hope you are getting a glimpse of how are we able to going to write the code, right? So I highly encourage you to pause this video here and try to write a recursive code by yourself, and then we'll see, right? So let's back to the coding section. So first, let's make a function. Let's make a function that will iterate for all the jobs available for each and every person, right? Right? Hmm. So let's start coding it. Also, before writing this code, I have also taken the help of writing the code from the discussion section as well as the editorial. So don't mind if there are something getting in common, right? The whole thing is that you should understand that if you're not able to solve the question, then how the flow is going, right? And I already gave you the flow, that how we are going to write the code, and you must write yourself first, right? So let's store the answer, and we will call a function. We will call a function here which will have our graph, right? Which will have our graph. We will have this m and we will have this n, right? Okay, so let's make a function now, and the function will be like int. Let's name it, and we will pass the graph. So I will be int g, right? Int m, int n, right? What I have to do first, I have to make a visited array. And why I need to make it visited array? I will make visited array for each and every job, for each job, and that will contains that which person has got which job, right? So let's make it, and let's make it a variable as match, right? So it will say that how many jobs are there. There are n jobs, right? So I will say int match is equals to new int n, right? And what this is depicting, the value of match of I is the applicant number assigned to the job I, right? Okay, so I hope you are clear to this point. Let me write it for you. Match of I is nothing but is the applicant number assigned to I. Hmm. So I will explain this all lines of code which you're doing, and we'll follow the same intuition I just showed you in my dry run. So for int I equals to 0. So since first of all the jobs are available, right? So let's mark it as -1, because we will use this -1 in our recursion thing to check that if the job is assigned or not, right? So okay, you can use any integer, -1 or -2, that is up to you. I'm just marking it -1 just to see that in the recursion when I will make those dry runs, right, that if the job is assigned or not, then you have to check it that. Okay, so match of I is equals to -1. Okay, okay, so we have this one answer here that will represent that the count of jobs actually, let's say we'll store it answer, right, in result. So this is nothing but the count of jobs assigned, right? Or maybe the number of persons placed. You can say it like that. And I will say for int u to v, because it's very conventional to use u and v for this graph edges. So for int u is nothing but a person, right? So we'll iterate for each person. For each person, we will iterate for every job, right? So for I equals to m, or we're using u, right? U plus plus. We are iterating for every person. Got it? And since for each and every person that we have to mark all the jobs as not seen for the next applicant, right? So let's mark it. So for that you have to make a boolean array, right? So since we are doing a not seen job, so let's make a array which has the name as seen, and I will say new boolean, and right, and initially the all the jobs that are not seen by this applicant, because we are about to process it, right? We are just checking it now. We have this thing that p1 and j1 has the connection using this one, but we do not know as of now, right? We are just iterating for each and every job, and we will get that confirmation using this g2d array, right? So as of now I am saying that each and every one is false. There is no connection between them, and by default it is false, right? So we don't have to do anything, right? Or if I just write the comment that what I'm doing, that marking all jobs as not visited, right? Now I have to see that if the applicant you can get a job or not, right? What we were doing, that we were always checking that if g of u of v is equals to 1, then we are assigning the job, right? So we will do, so we will, for that we will pass up to another function, because here we have to use the recursion thing, because for each and every applicant you have to check if you can assign the job, and if you cannot assign the job, then what if the next person can take up that job for you, right? Second case which I'm talking about is this one, right? Is this one is the second case, right? P2 can see that the J1 is already assigned to P1, right? But what if P1 could take another job, that is J2 and J3, because it have the lines between P1 J2 and P1 J3. So if it's possible for P1 to take another job, then P2 can obviously take the job J1 and will have the total count as 2, right? So that is the second case, and that is why we need the recursion here, right? So let's gets back to the code, and we will do the recursion. So let's make the function name as BPM, the bipartite matrix matching, right? And we will pass the graph again. So let's pass the graph again, for which it will help us to see that if there are existing connection between the job and the person, right? Then we will pass the match array, the M and the N. And if we are getting a true value from here, that is you can do this, you can assign this person here, then I will say this result plus plus, and at the end we just have to return the result. I will say return result. Now let's make the actual function. So up till this was a very clear thing. Now the main understanding thing will begin, where we have to handle the two cases. So let's make this thing. So okay, so I will say boolean. I will say boolean, and let's make this function as bpm, as we have already written up there. And I will pass int graph. I will pass int u, that is the person which I am searching for. Then I have to pass this boolean scene array, right? Scene. Then I have to pass this match array, that is match match. And then I have to pass this int m, and then I have to pass this int n, right? Exactly. So for each and every person, I have to try every job, right? I have to try every job. So I will say that for, and job was representing in a dry run with int v, right? So I will say int v is equals to 0, v less than how many jobs are there? There are n jobs, right? So I will say uh, v less than n and v plus plus, right? So if the applicant is like you have the possibility of taking the job, and that is represented by graph of uv1, right? So I will say that if graph of u and v is 1, then only you have this possibility of taking the job, right? Then only you can say that you have the the question is saying that p1 can be mapped with j1, right? If there is one there, right? And it should not be visited, this job should not be visited, right? So I will mark, so I will check it that if it is not visited, then only you have to assign it, right? So assigning it just means that you have to mark it visited. So scene of b is equals to true, mark it visited, right? Now there was the second case, that what if the second person came and he has to take the same job the p1 is taking, just to optimize the placement ratio, as you can say that, right? The more number of placements we have. So what we can write again is, hmm, so now this was the case that it was possible and not visited. Then you just have to assign it. But what if it is not possible, like the job was not assigned, right? Like if I just write the comment for you, that what are the case I am tackling is that if job B is not assigned, this is the case of not assigned. And what could be the possibility if it's not assigned? Or there could be one more possibility, that the assigned applicant for the job V, right? The assigned applicant for the job V has no alternate job available, right? That could be also be the case, right? What I'm saying is that assigned, let me write it for you and then I will show you this thing in the dry run, right? That assigned applicant has no other job available, right? Which is this case? This case is exactly this second case I explained you about. This person do not have the another job available, right? It only has J1, that is, but that is has been already marked as true by P1, right? That is already marked by true by P1. So what you have to do, you have to take the recursion thing now in factor. That if this P2 is not have the job, that means that the match array would be equals to 1. So we can say that if it is less than 0 and or if it is the same thing which I just said, or here the assigned app has no job available, then you have to recur, right? You have to recur for the to search for the next jobs. So I will just say that if match of v is less than 0, you can also write equals to 1 here. That's the same. So BPM of, you will pass the G here, right? And we will pass the match of V, right? And then scene array, and then match array, then M and N, right? Right. Hmm. So match of V, because of match of V, it is just the parameters, the person which we are looking for. So what it is happening here is that the P2 here is asking that P1, can you look for the another job that is available for you? That is J2 and J3. So I am searching for P1 job again, right? So that's what I'm writing here. The job which I am about to take, the P2 is about to take J1 job, right? But the J1 is already assigned to P1. So I'm asking P1 that please recur again, to please make the function run again so that you can search for yourself, right? So that's happening here. So I will say now that match of V is you, right? And I will say return true. That's it. And if it is not possible, like if P1 is not able to search for job for himself because there was no possibility, right? There was no this graph of u comma v for P1 that was 1, right? So it will say that no, I cannot search any job for me and I have to return false, right? What is this case? That this P1 has do not has these lines, this J2 and J3 that wouldn't have existed, right? Then it would have returned that no, I cannot search for any job. I cannot see that there was any job available for me. So I cannot help you and I will return false. So that is it. So that is it for the Boolean function, I guess. And the Boolean function ends here, as well as, yeah, there's one brackets now. Okay, that's great. So let me see if I have written everything correct. So just few changes I made here, that there was one spelling mistake here, that I made this match as an int. So you have to change that in your code, as well as this if bracket must be closing at line number 81, because this if should be in the nested if, because you have to check for this condition that the assigned job has no other job available, only if the possibility of P2 to J1 is available, then only you have to say that P1 search for J2 and J3, right? That's what happening here. The possibility should be available, then only you can ask another job to, okay, I need to shift in this position of your position now, and you can search for another job if possible, right? If not possible, we'll again return false. So I guess this is well and good. So I can give you a code walkthrough. So this is just the maximum match function, the function just to find for each and every person if the job's available or not, and to find actually a job available or not. There was two cases I explained you, right? Possible and not visited, assigned, and positive possible and not visited, but you cannot assign it because the another person has taken already your jobs, right? I ask him to search for again. That is it. And let's compile and run. Okay, so our output and expected output matches. And if I just show you that the code we have written, it is actually taking this value, that the job one is going to P3, the J2 is P1, and J5 is P2. So let me show you that thing also. Let me print the match array for you so that you can have a more clear observation, right? So let me print it for you. Where should I print that thing? I should print it here, right? Before returning the results, right? After all the recursion happens. So let me write this thing for you. For int x in match, I will say that system dot out dot print pr. Okay, so my spelling mistake, print and x plus this thing, right? And as we will see that the things we made in the dry run will come out at the same. So this is the array we got. Let us just verify this to have a more clear understanding, because we have written the code for this, right? So we should get a good understanding of it. Okay, so this is saying that this is a match array, this is a match array, right? This is a match array where the jobs are actually 0, 1, 2, 3, 4, right? And 2 and 3 jobs remain unassigned, as you can see. And this is the zero based indexing, right? So if it is saying 2 and 3 remain assigned, that means it is asking for 3 and 4, right? Because it is one based indexing in the answer, right? So it is saying that 3 and 4 are not assigned to any person. As you can see, this is not assigned to any person, not assigned to any person. And you can see that fifth job is assigned to one, and one is also like person one is nothing but the what p where is that? Yeah. So 0, 0, 1, 2 is the indexes of the persons, right? So our person is one started with the index 1, right? So 0 will be person 1, and this 1 is nothing but p2, and this 2 is nothing but p3. As we can see that p3 is assigned to 1. Can we verify that p3 is assigned to 1? Yes. And p1 it is assigned to job 2. p1 assigned to job 2. Great. And this, what is this? That p2 is assigned to job 5. P2 is assigned to job 5. So we are on the very clear page now. So if you are able to maintain your pace, maintain your dedication until the end of this video, you must have got a very clear understanding, and you must mention in the comments that yeah, I got the concepts clear, or else you have any doubts, ask them in the comment section, and we will see to it, right? So let's compile and run again, and we will submit it. So before submitting it, what would be the time complexity? As you can see, for we are iterating for each and every person, right? And then we are saying another person to go find your job. Maybe you have some, right? So this is one for loop, and there's recursion happening under for loop, which itself is taking O of n, right? So this whole function, BPM function, will take O of n square. This will take O of n square, right? And this O of n square is running under O of n. So the overall time complexity will be O of n cube. Let us verify what they have given. So O of n cube, and we have made the visited array for scene as well as the match array, right? So O of n will be the space complexity. And the constraint should be much lower if the O of n cube have to submit. Yeah. As you can see, the constraint is 10, 100, right? So if you do 100 power 3, it will be 10 power 6, which is obviously less than 10 power 8. So this 10 power 8 always holds true. You must watch this time complexity video to get a full understanding of it. It must be flashing up here, or you can just search in my playlist, right? So that is it. Now it's the time to hit the submit button, and we'll see for ourselves that how our code is reacting. So great, all the test cases passed, and I hope you were able to relate to the test to the question as well as the answer. And don't get frustrated if you're not. You just run a very simple test case for yourself. That is, I run one for you, you can run two for yourself, right? And you will eventually get it. So if you are very new to the recursion, you do not understand how recursion works, then I have solely made a playlist on the recursion. So that's the playlist I was talking about. Because of these topics, that is recursion, trees, graphs, and DPs, which are complex to understand for a beginner, that's why I have started my DSA series from recursion, and we'll cover the topics from the trees, graphs, and DP, and then we'll jump back to the topics of ANA and linked list, right? And you can also refer to my SD sheet. I will just keep on updating it as soon as I cover all those topics. So that's it for today's video. Few last thing, that this is my DSA repository. You can start and fork to get help with the source code, as well as you can connect to me on LinkedIn, on Insta, if you have any doubts or guidance, if you may want. And yes, feel free to ask any question in the comment section, and I'm open for your advice or encouragement for anything, any suggestions that you want me to include in the video. I'm open for that, and let's meet for the next week, that is day 112. Till then, keep learning, keep growing, and take care. Bye bye.